Estimating formworks for beams is similar with the procedure of estimating column materials. Check out how it is done here in quantity surveying. In this video, we are to estimate the formworks of beams in the framework. The columns included have identical size of 400 by 400 mm. The beam dimensions are also placed in the beam schedule. Interpret the plan carefully to estimate properly. There are 4 beam 1 along the top and bottom perimeter of the framework. 6 beam 2s are also found from the left and right perimeters and the middle horizontal spans. The remaining beams are tagged as beam 3, and they are found as the middle vertical spans. Estimate the forms on beam 1 with a size of 300 by 400 millimeters. The formworks are situated as the base where there is additional 2 inches length on both ends. There are also the 2 formworks on the sides with height of 400 millimeters. From the plan, the length of the formwork is the clear span of the beam, and that is 3.2 meters on centers less half of the column widths at both ends, resulting to 2,800 millimeters. For the width, compute the perimeter which comprises the length of the base, which is 300 plus twice of 2 inches, then add the 2 sides of 400 mm size, yielding 1,200 millimeters. The general computation for the number of boards is taken as the required area over the area of one board. So the number of MDF boards is computed as 2,800 times 1,200 over 1,200 times 2,400, which equals to 1.167 pieces. For the 4 beam 1 from the framework, the number of MDF boards is then 4 times 1.167 pieces, which turns out as 4.667 pieces. The frame is computed using direct counting. With continuous rib type forms and using the longer length of the board, we take the width of the base as 400 millimeters and the length as 2,400 mm. So the vertical frames have lengths of 2,300 mm. With 2.8 meters clear span of the beam, there is a remaining 400 millimeters. And taking out the 2 inches frame from top and bottom, the remaining height of the vertical frames is 300 millimeters. For the total length of the 2x2 frame, the solution includes 4 horizontal frames of 400 millimeters, the 3 vertical studs of 2,300 mm and 300 millimeters, which totals to 9,400 mm. To account for the required board feet of the 4 beam 1 members, we compute 4 times 2 by 2 inches with 9.4 meters converted to feet by 3.28, then divide this by 12, giving 41.1093 board feet. For the sides of 400 millimeters, take a form of 400 millimeters width and the length of 2,400, but the vertical frame will have 2,300 mm length. There would also be another form of 400 mm length, which shows that the length of the 2x2 frame is 300 mm. The total length is computed similarly as the base. The required board feet for the frame is then computed as 4 beam units times 2 by 2 inches with length of 15,600 millimeters multiplied by 3.28 to convert it into feet, then divided by 12. This results to 68.224 board feet. The total quantity for beam 1 frame is then 41.1093 plus 68.224, which gives 109.3333 board feet. Moving on to the second beam, which has two configurations. Let's start with the horizontal beam 2 of 300 by 500 size. The base is then the width of 300, then add the 2 inches frame on both sides, making the total width as 400 millimeters. The depth is 500 mm. The length of the MDF board is then the clear span of beam 2, which is 3.2 less twice half of 400 column width, which makes 2,800 millimeters. The total width of the form is then the base of 400 mm plus twice the sides of 500 mm, which makes 1,400 mm. With a general equation, take 2,800 times 1,004 divided by the area of a board, which is 1,200 by 2,400, giving 1.3611 pieces. Thus, for 2 beam 2 units, the pieces is then taken as 2.7222 pieces. For the framing, start with the base. The width is 400 millimeters, then take the whole span of 2.4 meters length of the board, which gives 2.3 meters length of the frame. There is also an excess of 400 mm to account for the 2.8 clear span. Another small form should be made out of 400 mm length, making the frame length equal to 300 millimeters. The total length for the frame is then 4 times 400 mm width plus 3 times 2,300 mm length plus thrice of 300 mm, which equals to 9,400 millimeters. The 2 units of horizontal beam 2 is then twice of 2 inches by another 2 inches with 9.4 meters into feet by 3.28, then divide everything by 12 to have 20.5547 board feet. For the sides, note that the depth of the beam is 500, so the width of the form is 500 mm. Take the whole length of 2,400 using 2,300 millimeters frame length. Then the second form has a length of 400, leaving 300 millimeters for the vertical frame. So the total length of the frame is then 4 of the horizontal frames of 500 millimeters plus 3 times the whole length of 2,300 and another 3 multiplied by 300 millimeters. Multiply these for the two sides. The result turns out as 19,600 millimeters. For the 2 units, side frame is then computed as twice of 2 by 2 inches with 19.6 meters times 3.28 feet per meter. Then divide everything by 12 to have 42.8587 board feet. Therefore, the total quantity of frame for beam 2 is 20.5547 plus 42.8587, resulting to 63.4137 board feet. The other configuration of beam 2 is the vertical units, and there are 4 of them. Start with the MDF boards, where the clear span is then measured as 3 meters, less twice half of the column width, giving 2,600 mm. The perimeter of the board is then taken as the base of 300 plus twice of 2 inches plus the two sides of 500 mm, yielding 1,400 millimeters. Knowing these parameters can help us compute for the required area used to solve for the number of MDF boards. That is, 2,600 times 1,400 divided by the area of 1.2 times 2.4 meters per board. The required quantity is 1.2639 pieces. With 4 beam 2 units, the required board is 4 times 1.2639, giving 5.0556 pieces. For the frame, start with the base with a width of 400 mm. The whole length then uses 2,400 mm with 2,300 millimeters frame length. Then add the needed form as the clear span is 2,600. The length is 200 millimeters, giving 100 millimeter frame. The total length is then 4 widths of 400 mm plus 3 times the whole length of 2,300, then another 3 vertical frames of 100 millimeters, and this results to 8,800 millimeters. The 4 beam 2 units then require 4 of 2 by 2 inches with 8.8 meters length converted to feet by 3.28, then divided by 12 to have 38.4853 board feet. The sides then have a width of 500 millimeters and full length of 2,400. So the frame is again 2,300 millimeters. The exact counts for 200 mm length with 100 millimeters vertical frame. The total frame length is then 4 of 500 plus 3 times 2,300 plus 3 times 100 mm. Take the length for the two sides, yielding 18,400 millimeters. The 4 beam 2 units then require 4 of 2 by 2 by 18.4 times 3.28 all over 12, giving 80.4693 board feet. The total frame required for this beam is then 38.4853 plus 80.4693, giving 118.9526 board feet. To complete the estimation for the framework, consider the third beam of 350 times 500 millimeter size. The length of the form is then 3 meters less the column width, giving 2,600 mm. The total perimeter for the MDF board is then the base of 350 plus twice of 50 and twice of 500, resulting to 1,450 millimeters. By the equation of area required over the area of available board, compute for the quantity as 2,600 times 1,450 over 1,200 by 2,400, which results to 1.309 pieces. The 2 beam 3 units then require 2.6181 pieces. The base frame is then computed as a width of 350 plus twice of 2 inches, that is 450 mm. The full length is again 2,400 millimeters using 2.3 meters frame length. The other form has a length of 200 to account for the 2.6 meter clear span of the beam. From the 200 mm required, The vertical frame then has a length of 100 millimeters. So the total length of the frame is then 4 of 450 plus 3 of 2300 with another 3 of 100 mm, giving 9 meters. For two beam 3 units, the frame is then twice of 2 by 2 inches with 9 meters length times 3.28 conversion, then divided by 12 to have 19.68 board feet. For the side forms, the width considered is 500 millimeters also, using the whole length of 2.4 meters, giving 2.3 meters vertical frame. The extra form is also of 200 mm length, accounting to 100 millimeters vertical frame. The total frame length is 4 of 500 mm widths plus 3 times 2300 with another 3 of 100 millimeters. There are two sides giving 18,400 millimeters. The two beam 3 units then need 2 times 2 by 2 by 18.4 by 3.28 divided by 12 to have 40.2357 board feet. Thus, the total frame quantity for beam 3 is 19.68 plus 40.2357, which equals to 59.9147 board feet. Now summarize the materials for the formworks. Beam 1 requires 4.667 pieces of board and 109.3333 board feet of frame. The horizontal beam 2 needs 2.7222 board pieces and 63.4134 board feet of rough lumber. The vertical beam 2 requires 5.0556 MDF boards plus 118.9546 board feet of frame. Beam 3 also requires 2.6181 MDF boards and 59.9147 board feet of frame. The whole framework then requires 15.0629 pieces of 4 by 8 feet MDF boards and 351.616 board feet of 2 by 2 rough lumber. Round-off quantities like taking 16 pieces of boards and 352 board feet of 2 by 2 frame. Note that the estimation does not account for any wastage yet.